All right, final exams are breathing down our necks, and you know what that means. It's crunch time for C++. But hey, don't stress. In the next few minutes, we're going to put together a rock-solid game plan, hitting the absolute T topics you need to know to walk into that exam and own it.
I mean, this note from an exam topic list, it just hits home, right? It perfectly captures that pre-exam feeling. There are just some fundamentals we have to nail down. So let's start there, get the basics right, and then we can tackle the tougher stuff with way more confidence.
So let's flip that switch from anxiety to action. By the time we're done here, you are going to have a super clear roadmap of all the C++ heavy hitters. Let's dive in.
First things first, compilation and linking. You write all this beautiful code, but how does it actually become a program you can run? This is like guaranteed to be on any final, so let's make sure we get it.
It's really just a three-step journey. First, you write your code in your .cpp files. Then, the compiler takes each of those files and turns them into these intermediate things called object files. Think of them as translated puzzle pieces. Finally, the linker comes in and stitches all those pieces together into one single runnable program.
And this shot of the whiteboard shows you exactly what that looks like in practice. That G++-C command, that's the compiling step. It makes your object file. Then the G++-O command links them all up to create your final program. See? It's that straightforward.
Okay, so we know how to build a program. Now let's talk about how it handles its memory. And that brings us to the topic that I know gives a lot of people headaches, pointers. But honestly, they can seem tricky, but the main idea is actually really simple. Let's break it down.
So every single variable in your program lives somewhere in your computer's memory. And each one has a unique address, literally, just like a house on a street has a specific address.
And if the address is the house number, then the value is what's inside the house. It's the actual data, the person living there. It's so important to remember. The location and what's at the location are two totally different things.
And that right there is the entire secret to pointers. A pointer doesn't hold a normal value like 5 or hello. Nope. All it does is hold the memory address of some other variable. It holds the house number, not the person inside. That's it.
This diagram from the whiteboard lays it out perfectly. Look, the variable x has the value 25 and it lives at address 0x123. Now look at the pointer p. It doesn't have 25 in it. What does it have? It has 0x123, the address of x. That arrow shows you exactly what's happening. It's just pointing to x.
So if the pointer only holds the address, how do you get the value it's pointing to? Well, that's where dereferencing comes in. When you put that little asterisk in front of the pointer's name, you're basically telling the computer, hey, don't give me the address, go to that address and give me the value that's inside.
All right, let's move on to functions. These are the Lego bricks of any C++ program, right? They let you organize your code and reuse it. And a super important concept for your exam is how you get data into these functions.
And this distinction is absolutely critical. With pass by value, the function gets a photocopy of your data. It can scribble all over that copy, but the original document is untouched. But with pass by reference, and you'll know it by that little ampersand symbol, the function gets the actual original document. It can change it. Now, why does this matter? Imagine you have a huge piece of data. Making a photocopy is slow and wastes memory. Handing over the original, passing by reference, is way more efficient.
Now let's talk about a special kind of function, a recursive one. This is just a function that calls itself. And the single most important part of any recursive function is the base case. That's the off switch. It's the condition that tells the function, okay, we're done, stop calling yourself. Because think about it. Without a base case, what happens? The function just calls itself forever. And each call gets piled onto this to-do list called the call stack. Eventually, you run out of room, the whole pile topples over, and your program crashes with a stack overflow. Your base case is your essential escape plan, your parachute.
Okay, individual variables are great, but sometimes you need to group related data together. For that, you need data structures. For your final, let's just zero in on two of the big ones, structs and vectors.
A struct is awesome because it lets you create your own custom data types. It's a simple process. First, you define the blueprint, like, say, a student struct that has a string for a name and an int for an ID. Then you just declare a variable of that new type. And to get at the individual pieces, you just use the dot operator, like mystudent.name. Easy.
Then you've got vectors. Think of them as arrays on steroids. They can grow and shrink automatically. For the exam, you need to remember two key methods: .pushback to add something to the end and .at to get something out. And here's a pro tip. Using .at is way safer than the old square brackets, because .at will actually check to make sure you're not asking for something that doesn't exist. It's a built-in safety net that can save you from some really nasty bugs.
So to make our programs actually useful in the real world, they need to be able to talk to files, right? And that brings us to our last major topic, file input and output, or file I/O. Here is your 4-step non-negotiable guide to handling files. 1. You open it. 2. You process the data inside. 3. You always check for errors using the .fail method to make sure everything went okay. And 4, and this is the one everyone forgets, you have to close the file when you're done. Forgetting this can corrupt your data or lock the file. Seriously, if you open it, you close it. Okay, let's boil this all down. Golden rule number 1, compilation. Think of your code files as individual players on a team. You compile each player into shape, then you link them all together to create your final winning program.
Golden rule number 2, pointers. Don't let them scare you. It's simple. A pointer stores an address. You want to know what's at that address? You just dereference it with the asterisk. That's the whole game.
And golden rule number 3, passing data. It's a simple choice. Do you need your function to actually change the original data, or are you just trying to be efficient with a big object? Then use pass by reference. Otherwise, pass by value is your friend because it keeps your original data safe and sound.
And there you have it, a solid game plan that covers the core stuff, from how your program is built to how it talks to files. You are so ready for this. Walk into that exam with confidence and just take it one problem at a time. You've got this. Good luck.